This video covers ODOT's Open Roads Designer Training, Section 305, Exercise A. And in this exercise, we're going to put in our proposed alignment for State Route 185. So I have ProjectWise Explorer open, and under my particular district and username, under the Design Training 1, 2, 3, 4, 5, 6, 401 Engineering, Roadway Base Maps, I've got my files. And I created two files in the previous exercise to house my proposed geometry. So we're going to open this BK004 file that we're going to use for our proposed State Route 185. Okay, the file is open, and the first thing I need to do is attach my survey information. So from the Open Roads Modeling Workflow, I'm on the Home tab, and I've got the Attach Tools icon here. So I'm just going to go ahead and select that and attach my survey information as a reference. So I'll use the Attach Reference button. I'm going to browse to the 300 Survey folder. So under my PID number folder, 300 Survey, Base Maps, I'm going to use the Fieldbook design file, and we're going to attach that. In ProjectWise, this may look a little different than what you're used to just in MicroStation or Power Geopack. But what I can do is pick a file and then add it to the list of files I want to attach, and then go ahead and continue to pick additional files. Instead of doing that, I'm just going to go ahead and attach this one, and then I'll go get any other files I need separately. So I'll hit OK, and this is going to bring me to the familiar Attach Reference dialog. And I'm using the Coincident World option here. My design file and my survey design file are both on the same coordinate system, so I'll use the Coincident World option. And I'm not going to use any nesting, so live nesting is turned on, but I have a nest depth of 0. So I'll go ahead and attach this reference by picking OK. And I'll use the Fit View option to fit that into my screen. So anytime I attach the survey, I'm in the habit of setting the terrain as the active terrain. So what I'm going to do is just zoom in a bit here on this so I can see the boundary of my terrain. Now in this particular file, the last person who was working on this survey information left the terrain feature set to only show the boundary. So it's possible you might see the triangles or the contours as well, but in this case I'm only seeing the terrain boundary. I'm going to use the element selection tool to select that, and I'm going to allow the cursor just to rest on that until I get the pop-up menu. And I'm going to use the second icon here, which is going to set this as my active terrain. Now, I'm working in a 2D design file, as we can see at the top. So what happens as soon as I set my terrain active, the software creates in this file a 3D model, and then that 3D model is attached as a reference to the model that I'm in. So I'm in the design model, and it has now made a new model named Design 3D and attached that as a reference. I can verify that if I want by looking at the Models dialog, and I can see that there's a Design 3 model that's been created in here. So now that I have my survey attached, I'm going to go ahead and turn off a few levels that I don't need to see. So in my Home tab under Open Roads Modeling Workflow, I'll find the level display icon. I'll select my Fieldbook file, and I'm searching by what's in use in that file, or I should say sorting by what's in use. I can sort alphabetically and then what's in use. And I do want to turn off a few things. There's a center of pavement, and this is not a geometric center line. This is a surveyed at the crown of pavement. I'm going to turn that off, and you'll see that line disappears. I'm going to turn off a few other things. I don't really need to see the break lines that were surveyed. I don't really need to see the random point locations or the shot markers. So there may be additional levels that you may or may not want to turn on or off. I'm going to leave it at that for now. Okay, now I'm ready to go ahead and start to put in the proposed geometry information. And for the purpose of the exercise in the ODOT's training guide, we've given you the information to put this in. So I'm just going to step through that. So I'm going to start by defining the feature definition that I want to use as I enter my geometry. So in the Geometry tab, one of the options under Standards is to open the feature definition toolbar. I'm going to go ahead and open that and dock it at the top, and I'm going to use the feature under Alignments for proposed alignment. So you can see the features that ODOT currently provides are generic, just for proposed alignment, driveway, existing alignment, and then scratch. And the idea of the scratch is maybe when you're working on laying something out and it's not really complete yet, you can use that feature definition just to put in some scratch graphics. So I'm going to use the proposed alignment feature definition, and we're going to make that active by clicking on the icon just to the left of that, which sets that as the active feature definition. So we're going to start with the geometry lines command. I'll go ahead and pick that command. And this is a line by 2 points. I guess I could look at the drop down here of the different options. So that's the line between points command. There's other options here for storing lines to and from elements, lines between arcs and whatnot. But we're just going to do a simple line between points. And in the tool settings, I can see that it's set to use the active feature definition. That's because I have this toggled on. And it has a default name for that, CLP_1. My tendency as I'm entering individual lines is not to worry about the name. I'll just let it use the default, and it will increment the number as I go and put in additional lines. Once I get this complete and make it into an alignment, then I'll set a line specifically for the alignment. So the subcomponents to make up the alignment, I'm not as concerned about their name, but when I do make the alignment, I do want to give that a name. So the applications ask me to enter a start point, and we're going to start this from this iron pin. I believe that's an iron pin. Float the cursor on it. Now it's a railroad spike. We're going to start from this railroad spike as our starting point, and then place a line going to the north from there. So I'm going to just snap in on that and accept that location as the start of my line. And now floating on the cursor, I have the distance parameter. And if I use the left or right arrow, I can scroll through the parameters. I have a direction parameter. So using the information out of ODOT's training guide, I have a distance of 1556.74. And when I hit enter, that locks that value. So I see the little lock icon. And as I scroll out, I'll see that distance is locked in. So now I want to enter the bearing. I should mention if I want to unlock that value, you use the end key to unlock that setting. So when I push the end key, that length is now floating. And I'm going to key that back in, 1556.74, enter. And I'll scroll over using my arrow, and I can enter the direction. Now notice these parameters can also be entered in the tool settings windows if you'd like. So for the direction on this is going at north, 0 degrees. And as a separator, I'm going to use the colon, 44 minutes, colon, 28 seconds, east. No spaces in this between the north and the east. I'll enter that, and that locks the value in place. So at this point, it has not drawn the element. The element's just displayed and locked in place. So now I'll just left-click to accept those parameters, and the element is now drawn into the file. Okay, for this next part of this, I'm going to start from that railroad spike and go to the south. So I'll enter my starting point by snapping to that. And using ODOT's training material, the distance on this one is 1595.31. And our direction is south 01, colon is my separator, 13:48 west. I'll accept that. And I can see the ending point of that. So from the ending point, I'm going to enter the next tangent line. Oops. Entering a start point. Let's try that again. This one is a distance of 1838. And our bearing is south 63:50:18 east. Accept that. And from the end of this one, I'll put in the last tangent. Distance of 650 feet. And our bearing on this one is south 03:35:00 west. So that defines my tangents or my traverse for the alignment. And now I'm going to come back in and fit in a spiral curve spiral on each of these. And when I do this, I'm going to use the Design Standards toolbar to assist me in the design of this. So we're going to zoom in to this first intersection of tangents. Actually, I guess it's my second intersection of tangents. Technically, the first one's just a deflection angle with no curve. And this one I'm going to put in a spiral curve spiral. So I'm going to use the Design Standards toolbar to help. So I'll pick Design Standards toolbar from my Standards option, and I'm going to dock that in the top. There's two drop-down menus here. The first menu is going to let me pick the library, and I also need to pick the design standard I'm using from here. Don't want to pick the design standard from the second one. That's really just setting the vertical standard that goes with the horizontal. So I'm using the, which one am I using? 202-7E2 lane. So I want to expand that and then pick my design speed from here. So I'm not picking the group and then picking the design speed in the second dialog. I'm expanding the group I want, picking the design speed from here. Okay, now I want to set this as the active design standard. So I'll turn that option on to toggle that as the active standard. So now I'm ready to go in, put in my spiral curve spiral, and this design standard will set the curve length and spiral lengths for me. So under the arcs commands, if I look down at arc between elements, I have a simple spiral and I have a spiral arc spiral. I could actually use either one of these. If I use simple arc, the design standard is going to be smart enough to know that this design standard requires some spirals, and it will put those in for me. So I'm going to go ahead and use that on this one. I'll do a second one, and I'll use the other tool for that. So it's asking me to pick the first element, so I'll pick my first tangent line, and then pick the second tangent line. And now it's showing me the solution floating on my cursor, and I can move it through the different quadrants to see the solution. So notice that it does have a spiral here that it's going to place, even though I'm in the simple arc command, and it has set my radius for me. So I'm just going to go ahead and accept that. And now it's prompting me, do I want to trim or extend these tangent lines? And I have options here. If I use my up arrow, I can scroll through the options. Of course, those options are in the tool settings window as well. But if I use up or down arrow, I can scroll through those. So I can trim both, trim neither one. The back element, which would be the first one that I picked, the head element, which would be the second. I'm going to trim both of these. So when I toggle to both, I need to left click to accept that parameter. And those elements are trimmed off. Now, the elements are still there. They still extend. They're just hidden from the limits of that. So if I float my cursor out here, I can see that that extension is still there, and I can actually select that extension. Okay, so that's my first spiral curve spiral. I'm going to go ahead and put in the second one. And I still have my design standard active. On this one, I'm going to use the spiral arc spiral option. I'm going to use that because I'm going to override the default spiral length that it's going to give to me. I'm also going to override the degree of curve on this. So on this particular one, I'm meeting the existing that's out there. This one I'm relocating, obviously. And the existing information that was there did not meet a 55 mile per hour design. So I'm going to change it just to match what we pulled off the existing plan. So this one I have a degree of curvature from the existing plan. And notice only radius is available as an option. So if I want to enter degree of curvature, what I need to do is just type in a lowercase d, and it is case sensitive, and then my degree. So this is going to be a 7 degree, 45-minute curve. So I'll just use my tab button to enter that value, and it's converted that to a radius for me. And my spiral length, I'm going to change these to 250 feet. So I'll go ahead and pick the first element, pick the second element, and then just accept. And I will trim extend both again on that. So since I'm using a design standard, notice on this one I have an icon showing here with an X. So that's telling me that this did not meet my 55 mile per hour design that was assigned to that. So that's just a warning symbol. The software doesn't allow you to actually correct that. you want to correct that, you would have to edit the elements yourself and change the value. So it's just telling you that this does not meet the design standards that you had selected. One thing to note, that when I put this in, even though I had typed in 250, it did force it back to the value that was defined by the standard. So I do want to change this. So what I did there is I used my element selection tool to select the alignment, and then the rules are displayed. So I'm going to change that to 250. And we're going to do the same thing with the second one over here. So I'll select that, and I'll pick the rule for the spiral length and change that to 250. Now, that particular error message can be reviewed using the Civil Message Center. So under Standards, I can pick Civil Message Center, and that happened to be docked. I'm going to pull that out. So it shows me one error. So if I click on the error here, actually these are not tabs, these are on-off buttons. So what I'm going to do is turn off the general microstation messages so I can just see only the errors or warnings here. So the message here says the arc radius is less than minimum, and it's giving me the design standard minimum value and the actual value of my curve there. So that's the purpose of that warning, and you can review those in the Civil Message Center by looking for the errors. And if I would change that to meet this particular radius, then that warning would disappear. So that completes exercise 305-A. Actually, that does not complete exercise 305-A. Okay, so now that I have my geometry defined, the next thing I want to do is make this a complex element. So to do that, I'm going to just temporarily turn off my reference display of my survey information, just so I've got a little cleaner screen display so I can see that. So in my references dialog, I'll turn that off, and I'm going to make a complex element from this. So in my geometry tools, I'm going to do a complex by element, and the method here is defaulting to manual. I'm going to change this to an automatic method. And what that is going to allow me to do is pick the first element, and then it will look for connecting elements within this maximum gap. I'm going to give this a name. CLP is my centerline proposed _ S for state route 185. So that name is coming from the Ohio DOT CAD standards manual and how I should be naming my centerline for proposed state route. So I'm ready to pick the first element, and when I float my cursor over the element, I can see, depending on which side of the element I pick, or which end, I see an arrow pop up that shows me the direction it's going to store that. So I want to make sure I get the beginning of the element at the right place so it goes in the right direction. So I'll pick that element, highlights everything that meets within that maximum gap, and then I will accept that. So this is now a single complex element. So when I select it, I can see the rules for that element. Some of the rules are not available to be edited, and that's the subcomponent here. If I need to edit that rule for that element, I could come down and pick the extension, and it will show up as being editable. Another way I could do it is when I'm selecting this, if I right-click, it'll go to the next element. Okay, so now that has been put together as a complex element. So the next thing I want to do is define stationing for this. So under the Modify group, I can define the start station. So in this, I'm giving a distance along the element and then a value at that distance. So I'm going to go right at the beginning, and my starting station is 385 plus 00 for this alignment. So I'll choose the element, and it wants to know the start distance. Well, I'm going to go right at the beginning, a distance of 0. Left click to accept that, and at that location it's station 385, so I'll left click to accept that. And that's just another rule that's assigned to the element. So if I select the element, I can see that rule has been applied up here for the stationing. I could change that if I needed to. The station can also be reviewed in the Open Roads modeling. So if I take a look in my Explorer dialog at the Open Roads model and expand that out under alignments, see the feature definition, and under that feature, any alignments that are stored there. So if I click on that alignment, it's highlighted in my plan view, I can see information in the properties about that. So if I expand that out, one of the things is the stationing, and there's the stationing values that could be edited there. You can also see that my design standard is listed there. So I could change to a different design standard if I wanted to. Again, that's not going to modify the graphics to meet that standard. It's just going to say, hey, this is the standard I want you to check against. And if it did not meet the standard, I would get those warning icons for any other things that did not meet the standard. If I wanted to, the standard could also be removed here just by right-clicking on that and taking that off. I'm going to leave that on there. So the next thing I want to do is annotate my center line. Now the annotation could be done in the geometry base map itself. Annotation could also be done in the sheet files when I get into the sheet clipping exercises later in these videos for ODOT's training material. I'm going to go ahead and place some annotation in this file. So to do that, I'm still in my Open Roads Modeling group under Drawing Production. I'm going to choose Element Annotation. Now I can do a single element, or I can do a model annotation. And there's also here an option to remove element annotations. The model would annotate everything in the model according to its feature definition and the annotation definition that's associated with it. I'm just going to do a single element. It's asking me to locate the elements, reset to complete. So I'll pick my first element. And if I had additional elements to annotate, I would choose them. I don't, so I'll just right-click or reset. And the annotation is going to be drawn according to the annotation definition for the feature that's assigned to this. And it is also going to use my annotation scale. So if I zoom in on this, I can see my beginning station drawn in, and the stations every 100 feet and tick marks every 50 feet. If I change the annotation scale to 50, I'll see all that increase in size, including the tick marks and everything. So that's a pretty nice improvement in ORD. Now, the annotation is drawn on 3 different groups with 3 different spacings. So there's a group with 100-foot spacing for the station labels, there's a group with a 500-foot spacing, and then a third group with a 1,000-foot spacing. So if I want to turn on or off those groups, I'm going to go back to the Home tab and look at the level display dialog, and I can see those groups listed here. So there's 100 curved data stations, 500, and then 1,000. Again, this is the interval for the labels. That's not the scale value. So there's 3 sets drawn in here currently, and they're drawn on top of each other. And the reason we had to do this is if I'm referencing this and using the annotation that's drawn in this file, I'm going to want to turn on or off whichever group I want. And so I'm going to just leave the 100 stations off and turn off these other options. But they are duplicate information. And so for example, if I will move the spiral data for this group and turn on the 500 curve data, you'll see that group is still in that location. So there are 3 separate groups of annotation. So after I've completed my geometry, I'm going to go ahead and close the file and check it back into Project Y. So I'll hit the File option here, and I'm just going to go ahead and hit Exit. And when Project Y prompts me to save this, I'm going to go ahead and check that in so it's loaded back up to the server. And now the file is released and it's free for someone else to edit if they needed to. So that concludes the video for proposed State Route 185.